Hi everybody, this is Channabasaveshwar K Choragasti, Department of Physics, K.L.E Society, City College, Gadag. So today I'm going to give a lecture on the introduction to the diffraction of light. So let's move on. Hello dear students, in today's class I'm going to deal with introduction to this diffraction chapter. In order to proceed to this chapter, we should study some of the concepts like particle theory of light, that is Newton's corpuscular theory, the meaning of wave optics, wave theory of light, which is given by Huygens principle, which is very important concept. In this, we will understand the meaning of terms like wavefronts and wavelets, and then we are going to study the meaning of the diffraction of light. So now let us study the Newton's corpuscular theory, which is given by Newton in 1675. So this theory explained only the particle nature of light. So nowadays we have accepted the fact that the light has dual nature, right? It is having both the particle as well as wave nature, right? But this theory explained only the particle nature of light. So according to this theory, every light source emits tiny particles called corpuscles, right? Every light source means there are two types of light source are there. One is artificial source of light and another one is natural source of light. The natural source of light is sun, and the artificial sources of lights are tube light, bulb, candle, lamp, etc. So these are the artificial sources of light. So now let us consider the tube light, which is the artificial source of light, which emits what? Which emits what? Tiny particles. These are the tiny particles emitted by this tube light, emitted by this tube light, right? So these tiny particles are called as what? Corpuscles, right? So what are these corpuscles? So these corpuscles are elastic, rigid, and massless particles. So these are elastic, rigid, and massless particles, and they are having different size and shape. So these all corpuscles are having what? Different size and shape, and they travel in straight line. And they travel in what? Straight line, and travels with different speed in different media. So these corpuscles travel with different speed in different media, right? And also this theory explained different colors of light, that is vibgyor, have different shapes and sizes. That is, the corpuscles having violet color have different sizes and shapes as compared to the corpuscles having the green color. So now, this Newton's corpuscular theory of light explained the phenomenon of rectilinear propagation of light. That is, the light moves in a straight line. So it explained what? The light moves in a straight line. There is rectilinear propagation of light, and also it explained the phenomenon of reflection of light and refraction of light. And this theory failed to explain interference, diffraction, and polarization, because these theories are based on wave nature of light. So in the same era, the Dutch scientist Huygens gave a theory called Huygens wave theory of light in 1678. So according to this theory, the light is considered as mechanical wave. So what do you mean by mechanical wave? A mechanical wave is one which require a medium to propagate, right? A mechanical wave is what? It is one which require a medium to propagate. Okay, so people asked Huygens that how the light travels from sun to earth. So he said that there exists a medium called ether through which the light passes from sun to earth. Okay, so here the ether's theory goes like this: a very dilute and highly elastic medium called ether is spread everywhere. Nowadays, the ether's theory is rejected because the light is considered as electromagnetic wave but not as a mechanical wave. So what's the good thing about this Huygens theory is it explains many phenomenons like rectilinear propagation of light, reflection, refraction, interference, and diffraction of light, but it failed to explain polarization of light. So in order to explain the polarization, the light should be considered as electromagnetic wave. So now comes the Huygens principle, which is very important principle. So in this, the first point is wavefront. So what do we mean by this wavefront? So it is the locus of all the points of a medium which are vibrating in a same phase. So now what is the term phase means? So let us consider a wave equation, a normal wave equation here. Y is equals to a sine omega t plus kx. Here, do you remember you have already studied this wave equation in your PU. Okay, so here y is displacement of a particle, t is the time here, and x is the displacement of wave here. So this whole term is called as what? Phase here, right? This omega t plus kx is called as phase here. Okay, now let us concentrate only on the phase term here. Now let us consider a point source as you can see here in the diagram, which emits the light in all the directions as you can see here in this figure. So now let us consider the point source is in a 3D space which emits the light waves in all the directions in a 3D space. Okay, suppose at time t is equals to t1, the particle is at a distance x from the point source, right, which is having the phase omega t1 plus kx, right? Suppose at time t1 consider a particle b which is at a distance x from the point source, which is also having the same phase omega t1 plus kx, because here the time t is equals to t1, and also the particle c at a distance x from the point source at time t is equals to t1 is also having the phase omega t1 plus kx, and so on up to h here, particle h, so which is also having the same phase omega t1 plus kx. So all these particles a b c d e f g h r all are having what? Same phase here, right? So now let us draw locus to all these points a b c d f g h which are uh, vibrating in a same phase, forms a circle here. So this locus of all the points which are vibrating in a same phase are said to be what? Wavefront. Okay, so this forms the circle here. So we have considered this as a three-dimensional space, right? So it forms a sphere, right? So this locus of all the points of a medium which are vibrating in the same phase are said to be what? Wavefront here. So this this S is what? It is the point source, right? So the point source produces what? Spherical wavefront. As you can see, the point source produced the spherical wavefront here. The second point of Huygens principle goes like this: the direction of propagation of wave is always perpendicular to wavefront here. So consider the point source S here, which produces what? Spherical wavefront here, right? So now consider this spherical wavefront as sphere, right? So all these light waves are normal to, so all these light waves are what? Normal to this sphere here. So any straight line which is normal to sphere is said to be what? Perpendicular to that sphere, right? So the direction of propagation of wave is always perpendicular to what? Wavefront. Now let us consider the third point of the Huygens principle, that is the types of wavefronts. So in that, the first type is spherical wavefront. So the spherical wavefront is produced by the point source of light. As we consider here, the S is a point source which produces what? The spherical wavefront here, right? So consider another spherical wavefront here. So now the point A will be having the phase omega t plus omega t1 plus k x1, right? So now consider the point on this another wavefront here, that is a dash. So it is having the wave uh, phase what? Omega t1 plus k x2. So the phase of the points on this wavefront will be different from the phase of the points on this wavefront. So both these wavefronts are having different phases. The second type of wavefront is plane wavefront. So it is produced by the source of light at infinite distance. The source at infinite distance produces what? Parallel rays of light, as you can see in this figure. So the locus of all the points which are vibrating at same phase on these parallel rays gives what? This plane wavefront here. As you can see, the plane wavefront here. The third type of this wavefront is cylindrical wavefront, which is produced by the linear source of light. Here S is what? The linear source of light here. Okay, which produces the light waves in all the directions, right? In all the directions. So the locus of all the points which are vibrating at same phase on this light waves produces what? Cylindrical wavefront, as you can see in the figure. The fourth point of Huygens principle goes like this. Every point on a wavefront acts as a source of secondary disturbances which emits their own wavelets called secondary wavelets. So now consider a point source here which produces a spherical wavefront. So every point on a wavefront acts as a source of secondary disturbances. So these are the points. These are the points on this wavefront. Okay. So every point on a wavefront acts as what? Secondary disturbances which emits their own wavelets. So this point emits its own wavelet. So this point emits its own wavelet. This point emits its own wavelet. This point emits its own wavelet. So and so on. All the points on this wavelet produces what? Its own wavelets. So all these wavelets are called as what? Secondary wavelets. So all these wavelets are called as what? Secondary wavelets. The fifth point of Huygens principle is very interesting. So the fifth point of Huygens principle goes like this. The common tangent on secondary wavelet in forward direction gives new wavefront. As you can see, these are the secondary wavelets here, right? So the common tangent on secondary wavelet in forward direction. So this is the common tangent. This is a common tangent on these secondary wavelets in forward direction, not in backward direction. In forward direction gives what? New wavefront. So this is what? New wavefront. So this is all about the Huygens principle. Let us study the meaning of diffraction of light here. Okay, the bending of light waves around the edges of an obstacle is called as what? The diffraction of light here. So consider this is an obstacle. So this is an obstacle here. An obstacle is nothing but the barrier, or we can say a thing that blocks one's way, right? So consider the light waves traveling in this direction here. Okay, so this is the screen here. This is a screen. So so if the light travels in a straight line even after hitting the edge of an obstacle, so this region would be the dark region here. So there will be no encroachment of the light rays in this region. So after hitting this edge, the light will be bent like this. So the light will be encroached or enters in this dark region. So only this region will become what? Only this region will become what? Dark region. Okay. So the definition of diffraction is the bending of light waves around the edges of an obstacle. There will be bending of light rays around the edges of an obstacle is called as what? Diffraction of light. And then the encroachment of light waves in a dark shadow region, as we can see in this figure.